These are the notes for 18.4, and really all this section is about is problem solving using this trig that we've learned. In solving right triangles, we can use right triangles for lots of different word problems, essentially, different real-life situations. Solving a right triangle can be used to determine side lengths or angle measures. In lots of different situations. And so this section is just simply kind of how do we apply what we know to these different situations. So letter A says a shelf extends perpendicularly 7 inches from a wall. So the shelf goes out 7 inches from the wall. You want to place a 9-inch brace, so A, B, it says is your brace, under the shelf as shown, to the nearest 1/10 of an inch. How far below the shelf will the brace be attached to the wall? So essentially it's asking what is the length of CB. And the second question, to the nearest degree, what angle will the brace make with the shelf? So what will it make with the shelf? And then ultimately with the wall. So we'll start with the first question. What is the length of CB? And since we know two of our side lengths here, we are working with a right triangle, which means we can use the Pythagorean theorem. So x squared plus 7 squared has to equal 9 squared. So x squared plus 49 equals 81. Subtract 49 from both sides. X squared equals 32. And if you square root both sides, x equals 5.7. So CB is going to be 5.7. 5.7 inches. Okay, so that's that. And then from there, we now want to know what our angles are. So I'm going to use the two whole numbers because those are a little easiest for me. And I'm going to start with angle A since that's the first one that was mentioned here. So if I'm talking about angle A, then this is going to be my opposite. It's going to be hypotenuse and adjacent. And so I'm working with A and H. Oops. A and H, which means I want to use cosine. So cosine of A is adjacent over hypotenuse. So cosine of A is 7 over 9. I need to take the cosine inverse of both sides. To get rid of my cosine. So angle A is the cosine inverse of 7 over 9, which, if you do on a calculator, is 38.9 degrees. And so we'll round that up. Typically, we like to round angle measures up to the nearest whole angle. So we're going to say 39 degrees. And if angle A is 39 degrees, A, B, and C all add up to 180, and A and B have to add up to 90 since C is already 90. So 39 plus B has to equal 90. Subtract 39. So angle B is 51 degrees. And just like that. Okay, so we can use trig, we can use our Pythagorean theorem. It all just depends on the situation and what it calls for. And we can use it to find a variety of things. We found a side length, we found some angles, and we can use all of that pretty much in one problem if we need to. Okay, so letter B says a building casts a 33-meter shadow when the sun is when the sun is at an angle of 27 degrees to the vertical. So they label that right there. How tall is the building to the nearest meter? So I want to know, how tall is the building? How far is it from the top of the building to the tip of the shadow? So ultimately, what will that end up being? FD. And what angle does a ray from the sun along the edge of the shadow make with the ground? So what is this angle down here? That one's kind of easy. We'll answer that one first, because this has to be a 90-degree angle because it's straight up and down, because that's how we build buildings. So if the top angle is 27, 27 plus angle D has to be equal 90. So if we subtract 27 from both sides, angle D has to equal 63 degrees. And so now we're going to find both H and X in this case. So we'll start with the height first. Doesn't really matter, but we'll start with the height first. We'll use our 27-degree angle since that's the one the problem initially gave us. And so we know our opposite. Looking for my adjacent, we also have a hypotenuse. And so since we have opposite and adjacent, O and A, we're going to want to use tangent. So tangent of 27 equals 33 over H. And multiply both sides by H. So H times the tangent of 27 is 33. Then divide both sides by the tangent of 27. So H equals 33 divided by the tangent of 37, which is 64.766 meters. Or we can round that to, does it give us anything to round to? To the nearest meter. It's going to be the nearest whole number. So we're going to do 65 meters. So the height of my building is 65 meters. And then to find X, we're going to do the same process, again using 27. Now we have our opposite and our hypotenuse, O and H, means we want to use sine. And I'm just going to kind of break this up a little bit. So sine of 27 equals 33 over my hypotenuse, which is x. Almost the same exact process as before, except now we're using sine. We have x times sine of 27 equals 33. Divide both sides by sine of 27. And so x equals 33 divided by the sine of 27. Which is 72.689, or if we round to the nearest whole number, 73 meters. And there we go. Okay. So again, it all just depends on what we're looking for. You can pick whichever reference angle you wanted. Right at the beginning, we found angle D, so if you wanted to use 63 as your reference angle, you could. You just have to then change which sides you want to use. And so there's always kind of a couple different ways you could do this, as long as you make sure you decide which angle you're going to use as your reference point, and then label your sides and go with that. Okay, you just have to make sure that you establish that, and then you should be good to go. So letter C, for building safety, the angle a wheelchair ramp makes with the horizontal should be no more than 3.5 degrees. What is the maximum height of a ramp of length 30 feet? What distance along the ground would this ramp cover? Round to the nearest tenth of a foot. Sketch and label a diagram to represent the situation, and then solve. So we have a wheelchair ramp that's going up to probably some door. And so it says the ramp has a length of 30 feet. So the ramp itself is 30 feet. And it says the angle the wheelchair ramp makes with the horizontal should be no more than 3.5 degrees. So horizontal is side to side. So that's going to be this angle down here, 3.5 degrees. And so the maximum height of the ramp is ultimately going to be this side to the left. And then what distance along the ground will ultimately be this side x down on the bottom. Okay, the ground is at the bottom. So to do both of those, again, 3.5 is going to be my reference angle. We're going to have opposite, adjacent, and hypotenuse. So starting with the height, we're going to use O and H, which is going to be sine. So sine, let's try that again. Sine of 3.5 equals H over 30. Multiply both sides by 30. So H equals 30 times the sine of 3.5. And so the sine of is 1.83. So if we round to the nearest tenth, the height is going to be 1.8 feet. And then to find x, our distance along the ground, we're going to do a similar thing here. Now we're using adjacent and hypotenuse. So now that we're using adjacent and hypotenuse, we're going to use cosine. So cosine of 3.5 is x over 30. Multiply both sides by 30. So x equals 30 times cosine of 3.5. Which is 29.94 or 29.9 feet. Okay. So again, not too bad. It's just a matter of setting it up, making sure you can draw a diagram if it's not given to you, and label your sides in such a way that you know what you're working with. Okay, again, when it comes to trig, the biggest thing is once you find your reference point, label your opposite, adjacent, and hypotenuse. A lot of times that'll kind of help let you see what you're supposed to be using. Now on the back side here, a couple more word problems, but just to define a couple terms before you work on these. Okay, I'm not going to go through these, but I suggest you work on them and see how you do on them, and then you can ask me next time we meet that if you have any questions or if you want to check your answers. The first couple things are angle of depression and angle of elevation. Depression, you should think like pushing down on something, like you're feeling really down, right? You're depressed, you're sad. So you're pushing down on something, so you're going down from the horizontal. So there's this horizontal line here. So the angle of depression is the one going down from that line. An angle of elevation, right, when you take an elevator, the whole purpose is usually to go up. So when there's a horizontal line and you have an angle of elevation, you are going up from that horizontal. Okay, so anytime they mention depression, you're going down, elevation, you're going up. So over here to the right, I'm going to give you a moment to pause the video and see if you can label each of these as an angle of depression or elevation, 1, 2, 3, and 4. I'm going to put the answers for these on in just a second, but I want you to try this because then I think that'll give you a better idea of whether or not you understand what the two differences are. So go ahead and pause right now. So angle 1 is coming down from this horizontal up above. So angle 1 is depression. Angle 2 is coming up from this guy's line of sight right here. So that's coming up this way. So angle 2 is going to be elevation. From that same horizontal, that same kind of eyesight of the gentleman, angle 3 is in between those two. So it's kind of down from his eyesight. So angle 3 is another angle of depression. And then angle 4 is this angle right here. That one is coming up from this ground level where the ocean is, or where the little lake is, whatever it is. And so angle 4, since that's coming up, is going to be an angle of elevation. Okay, so I highly encourage you guys to work on these 3 before moving on, just to practice it a little bit. And then, like I said, if you still have some questions, if you want to check your answers there, we can talk about it, and I'll see how you guys did.